All right, to start out this lesson, we're going to talk about just numbers and how we categorize them. So I have a nice little organizer. It's an empty one right now. If you'd like to draw this in your notebook, feel free to make a copy. We have 1, 2, 3, and then a fourth larger square or circle. It doesn't really matter what shape it is. And we're going to be filling those blanks in as we talk. I do want to give you a heads up that in any lesson, including this one, you are going to want to be keeping notes. I have a little sample page here. The way that I've organized it is at the top it says lesson title. So we've already said that our title today is numbers and their properties. So you can write that up at the top, and then the date, just so that you have an easier time finding your information later if you need to study for a test or something like that. And then I have two categories. The top one says vocabulary and the bottom one says examples. Now I've roughly divided my page into two different sections. This section we have a lot of vocabulary, so maybe you want to start the examples down like 3/4 of the page, something like that. The reason I recommend you do this is that we're going to be talking about vocabulary all through the lesson. But if you keep your vocabulary terms up at the top, then later when you're looking through your notes and trying to find information, you don't have to be searching several pages of notes to find that information. The vocabulary will always be right at the top. So that's just a little hint on a good way to organize yourself. That being said, this section could go within the vocabulary because everything we talk about in this organizer is going to be a vocabulary term. So let's talk about numbers. What is the simplest kind of number that exists? And I suppose it depends on how you define what simple means. I'm going to define it for us as the numbers that we see in the world. So things that, as if I was a caveman out in the middle of nowhere in my cave, I guess that would make me a cave woman, and I stumbled out of my cave early in the morning and saw a huge field of flowers and was amazed by all the flowers that were out there. How would I identify numbers in that kind of a raw, uneducated sense? Here is how I would describe that. Maybe I would come out and see that flower and I would look at it and I would see there are 5 petals on this flower. So I wouldn't necessarily use the word 5, but I would identify that I have this many petals on a flower. So the number 5, I would consider a number I see in nature. Or maybe I come and I see a clump of flowers and there are 10 flowers stuck in that clump. 10, again, I may or may not have a word for 10, but I'm probably going to come up with a word for 10 very quickly because 10 is a number I can identify, I can see in nature. There are 10 flowers in front of me. So 1, 2, 3, 4, 5, any number that's a whole quantity and is a visible quantity, I'm going to call a natural number. It's a number I see in nature. Now, let me explain one number that's not a natural number that you might think is. 0 is not a natural number. You may ask, why not? Why is 0? 0 seems like an easy number, just like 1, 2, 3, 4, and so on up to 100. However, here's what's weird about 0. 0 is not visible. 0 is kind of theoretical. It's a little philosophical. It's a little bit too high up there in knowledge for our caveman or cavewoman to identify 0. And actually the concept of 0 is something that we see that human beings interact with more and more over time. Like now the concept of 0 is very easy for us to understand, but it's not natural. It's not seen in nature. 0 represents something that doesn't exist. Think about that. 0 is a number about something that doesn't exist. So we're going to start with the natural numbers. And what I'm going to do is on my organizer, and you might want to do the same, is in this small box on the inside, I'm going to write the term natural. And I'm going to actually write it out, I'll show you in a second, with the example of numbers 1, 2, 3, and so on. So here is how I have written that. We have natural numbers on the very inside, and it's 1, 2, 3, and so on. So any whole number quantity, but not 0, because 0 is too philosophical for our very natural caveman. Okay. However, if that bothers you because you feel like 0 really should be included, that is actually going to be our second category. Our most basic category of numbers is the natural numbers. Our second, it's just a little bit more complex than natural numbers, is whole numbers. And there's only one difference between whole numbers and natural numbers. Whole numbers include 0. So in the second box, I'm going to write whole for whole numbers. And I'm going to say that that is number 0, 1, 2, 3, and so on. So let me show you that so you can put that on your organizer. So we have natural numbers, that's 1, 2, 3 whole quantities from 1 and up. We see those quantities in nature. And then my second category is going to be whole numbers. So whole numbers, whole quantities including 0. We include the more abstract concept of 0. So 0, 1, 2, 3. So far so good. We haven't done anything too crazy yet. So we have natural numbers, we have whole numbers. How do we take whole numbers and make them one step more complex in a good way? How do we make them a little bit more useful to us? Well, in caveman land, apparently you didn't need to worry about being in debt to your neighbor. But after a little bit of time went by, we had to come up with numbers that would represent being in debt or having less than 0, rather than just having positive quantities. And this is where we come up with both positive and negative numbers. So if you notice in natural numbers, in whole numbers, there are no negatives. Those are the numbers that you learn in kindergarten and first grade because they're pretty concrete. You can understand present quantities, things that you can see. But in the real world, we also need to be able to talk about numbers that are absent. If I owe you $4, then I am talking about the quantity -4, not just the fact that I physically could have $4, that would be +4, but the fact that I could owe you $4, that would be a -4. So the concept of positive and negative comes in on the next level up, and we call those integers. So I'm going to write that down for us. Integers, I'm going to show you in a second, and I'm going to label that as the negative kind of whole quantities up into the positive whole quantities. And I'm going to do that just like this. So we had natural numbers, we had whole numbers, now we have integers. See, the whole numbers started at a point like on a number line, like 1 or 0, and moved up. But integers can go either way. It can go in the negative direction or it can go in the positive direction. So I have -3, -2, -1, 0, 1, 2, 3, and I have this sort of the ellipses, the dot, 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 dot. I can go this way or I can go that way, as long as I'm still dealing with whole quantities, whether they be whole positive quantities or whole negative quantities. So we're moving up. Natural, whole, integers. What's missing? You might notice that in mathematics we talk a lot about fractions, and none of these categories include fractions. So the last category in our first organizer here is what we call the rational numbers. Now let me write out rational here on the top because I want to show you something. Rational numbers. And I want you to look at this first part of the word. We have the word rational, and I've underlined this first part of the word, which says ratio. That's not an accident that that word is there. The reason that we call rational numbers rational or ratio numbers is because they include any number that you can write as a ratio. So ratio, you think of, I went to an event and there was a ratio of 1 to 2 boys to girls. So that means for every one boy, there were 2 girls at the event. Or there was a ratio of 5 to 6 cucumbers to tomatoes in my garden. That means that there were 5 cucumbers for every 6 tomatoes in my garden. I wish that was the case. I have a lot more tomatoes than cucumbers. So ratio, or rational numbers, is the term that we use to describe all the whole numbers, but also fractions as well. So 1/2, 3/4. We could do improper fractions, like 5/4. It doesn't have to be 4/5. A rational number could be 5/4 as well. In fact, even the whole numbers are technically numbers that can be written as a ratio. So like the number 2, I could write that as 2/1, or I could write it as 4/2. So that counts as a rational number. That's why these categories are inside of the rational category, because everything here is a rational number. Even 0. 0 can be written as a rational number, as 0/1 or 0/5, because that number is a ratio. But when you simplify it, it becomes just the number 0. So all of these numbers are rational or ratio numbers, but there are also numbers like 1/2, 3/4, 5/4, even -5/4. So I'll show you how I've written that here. Just some examples. This isn't an exhaustive list, but these are an example of rational numbers. And it's also important to think about the fact that that decimal numbers can be ratios as well. So the number like 0.1 or 0.5. I'm going to show you here. 0.1, 0.5, those could be rational numbers as well, because 0.1 is just 1/10, or 0.5 is just 1/2. So even though they're not currently written in this form as a ratio, they can be written as a ratio, so they are rational numbers. All right, so this is almost all of our numbers, except if you think about it, not all numbers can be written as ratios. Think, for example, of the number pi, right? 3.14159 and so on and so forth, right? There's no way to write the number pi as a ratio. Also, if you ever play around with your calculator and try to divide 1,000,000 times and multiply by the square root of 5, and then all of a sudden you come up with this crazy long number that just keeps going, 0.7295364, whatever, and it just keeps going. There's no way to write that number as a ratio. That is not a rational number. So what do? That doesn't fit within this category of numbers anywhere. So what we need is another term, and we're going to call those numbers irrational numbers. And I will write that here so that you can see the spelling. Irrational numbers are just numbers that cannot be written as a ratio. So we said pi is an example. The square root of 5 is an example. The negative square root of 5. Or just random jarbles of numbers that can't be written as a ratio at all. So let me show these examples to you. So the irrational numbers are numbers that cannot be written as a ratio. Pi, you have our square roots, or numbers that just go on and on and on and can't be simplified. The reason I have these on 2 separate pages is because all of these numbers, these numbers exist in the sets just the way that I've described them here. So all of the natural numbers exist within all of the whole numbers, right? But the whole numbers add something new. It adds 0. All of the whole numbers exist within the integers, but the integers add something new. It adds all the negative numbers. And then the integers exist within the rational numbers, but the rationals add something new, the idea of fractions, quantities that aren't whole. They're part quantities rather than whole quantities, like 5 or -5. Both of those are wholes. One is just a positive and one is a negative. So all of these are related to each other. The irrationals are unrelated. They're part of a totally different set of numbers. Pi is never going to fit into any of these categories. The square root of 5, same thing. Never going to fit into any of these categories. It doesn't fit into the idea of any whole or rational quantity. So that is our organizer about how we label numbers. In this next section, we're going to look at a couple examples and decide how we label them. So if I give us a number, can we decide which category or categories it falls into?